First of all, to happy morning to all of you, my dear friends. My today's topic is very easy. There are only two reaction. First one is Wagner-Mervin reaction. Another one is dienone phenol rearrangement. So, what is the specialty of this reaction? What are the mechanism? We will see in further slide. So these are simple content. First one is what are the actual reaction, what is specialty of it, then mechanism, then application, and fourth one is very important topic, that is cationic rearrangement. What is the cationic rearrangement? We will see in further slide. So first we have to deal with Wagner-Mervin rearrangement. Is there any reason behind the name of the reaction? No, it's very simple. The reaction is invented by the well-known scientist, that is Wagner. That's why name of the reaction is like this. What is this reaction actually? If you see, it's a simple conversion of a alcohol to the olefin. What is olefin? The compound which contain double bond, or a double bonded compound we can easily see olefin. If you see the reaction, the alcohol which works as a reactant when get acid catalyzed, because we are using catalyst as acid, there is a formation of a alkyl, that is double bonded compound, that is also known as a olefin. So what is actually Wagner-Mervin reaction? How does it take place? If you see, there is a migration of a alkyl group. If you see in the reaction, the R1 group get migrated to the another carbon, that is adjacent carbon. This reaction is catalyzed by the acid, that's why it is acid catalyzed reaction, and the conversion of a alcohol to the alkene, that's a simple phenomena of this reaction. If you see, there is a red color highlighted one word, that is alpha dehydrogenation. What is the meaning of a alpha dehydrogenation? The remole of a H atom from the alpha carbon atom. What is alpha carbon atom? That carbon atom at which functional group is attached. So this is general mechanism. If you see the alcohol, in alcohol there is a presence of a OH which extract the proton, formation of a OH2. We all know that oxygen, the valency of a oxygen is 2, but now here there is a valency becomes 3, so it get increased, so oxygen carries positive charge which is not stable, so removal of a H2O molecule and a formation of a carbocation. But if you see, carbocation is again secondary carbocation which is not stable like a tertiary, so there is a shifting of a carbocation and formation of a new carbocation. It is quite stable because it's a tertiary, and again removal of a H plus atom, because we are using acid as a catalyst, and catalyst is not consumed by the reaction, it just used to increase the rate of the reaction. If you see the final product, there is a formation of a alkene, that is olefin. If you read the notes, the mechanism begin with protonation of alcohol. You can clearly see into the reaction by the acid, that is the catalyst, and release the water to forms a carbocation. So I have already tell you that there is a carbocationic rearrangement. What is it? We will see in further slide. So these are simple just application. If you see at the reactant side, all are the simple alcohol, and if you see the product, all are the olefin. There is a presence of a double bond. All are the acid catalyzed reaction. But there is a one thing I have to mention. If you see the migration of a alkyl group, if you see properly, you get idea that bulkyl group get always migrated. If you see the second reaction, there is a C2H5, that is a bulkyl group, then CH3, that is the bulkier alkyl group, so it will get migrated. If you see in the product in the second reaction, and you find the actual phenomena. So what is dienone phenol rearrangement? As its name suggests, diene indicates a double bond, one indicates the presence of a ketone, and phenol, that is the product. If you see the reaction, there is a simple conversion of a diketone to the phenol. If you see the reaction, at reactant side there is a presence of a ketone, at product side there is a presence of a phenol. This reaction carried by the H plus, that's it, acid catalyzed. So now what is the actual dienone phenol rearrangement? The 4,4-dialkyl cyclohexadienone, it's treated with HCl, it converted to phenol. So it's simple, ketone get converted into the phenol. What is 4,4-dialkyl? That is the substitution at the fourth position. This reaction also catalyzed by the H plus, that's it, acid. So mechanism, if you want to see the mechanism, in first step the ketone abstract the proton, the lone pair present on oxygen abstract the proton, so formation of a OH. Again the valency of a oxygen is 2, we know that, but here the 3 bonds are there, so oxygen carries positive charge which is not stable, so oxygen abstract the electron from a double bond present on a ring. So there is a formation of a carbocation into the ring, and presence of a carbocation in the ring which is not good, which is not stable. So shifting of a carbocation takes place as the conjugation plays important role in a ring, and presence of a carbocation in the ring which is not stable. Therefore continuously shifting of a carbocation take place, and at last there are some resonating structure, and at last if you see the final migration of a alkyl group take place. I have purposefully indicated by the red color, that is R2, And if you see the final product formation, that is the phenol. So now there are two types. One is alkyl migration, another one is ring migration. What is alkyl migration? If you see the first reaction, the red line shifted from one carbon to the neighboring carbon. That is just shifting of a alkyl group, that is the CH3 group. But in second case, what is ring migration? If you see the R group, which is remain at the same position, but whole ring gets shifted. That is known as the ring migration. So now application, if you see the again one side is all are reactant which are the ketone, and if you see the product side, all are phenol. But here one thing I have to mention, if there is a both are electron donating group, then more bulkier or electron rich group will be migrate. If you see the first reaction, there are two alkyl group, that is C6H5 and CH3. From that C6H5, that is phenyl group, get migrated, which is electron rich. And in case of a third example, it is very important. If one of the group is electron donating, in one of the group is electron withdrawing, then definitely electron withdrawing group will be migrated. That's why I have purposefully indicated the electron withdrawing group by red color. If you see the third example, you will get idea. So cationic rearrangement, what is cationic rearrangement? What is cation? We should know. Cation is like just intermediate which is formed during the reaction, which is not stable. That's why rearrangement within the molecule take place and final product formation take place. In this way, we all know that primary and secondary carbocation is not stable like a tertiary carbocation. That's why up to tertiary carbocation, rearrangement into cation take place and final formation of the product take place. There are some examples of a cationic rearrangement, that is SN1 also, and the Wagner-Mervin and dienone-phenol rearrangement, both are the example of a cationic rearrangement. There is a last note that Wagner-Mervin rearrangement is a class of a carbocation 1,2 rearrangement reaction in which hydrogen alkyl or aryl group migrates. What is 1,2 rearrangement? If you see properly all the reaction, there is a migration of a alkyl group from one carbon atom to adjacent carbon atom, not any other position. That is important. So acknowledgement, I would like to say thank you to our Pavra sir that they had given chance to me represent this slide. Then I would like to say thank you to our principal and vice principal. They had given chance to me to represent this organic slide, to collect some organic reaction, to collect some knowledge about the some name reaction, which will be definitely important in your future. So reference are very easy, which is very famous and well-known book. First one is Organic Reaction Mechanism by V.K. Ahulvia. Then Reaction Rearrangement and Reagents by S.N. Sanyal. And the last one is Name Reaction, GLAC, which are famous books. And at last, thank you everyone and be safe.